For number 1, the first thing that you need to do is determine which of the elements are being oxidized and which of the elements are being reduced. And we can tell that by looking at their oxidation number. So first, you'll need to assign them an oxidation number. So remember that elements that have a charge, that is the oxidation number. So for iron 2+, the oxidation number is +2. For an element in its elemental state, the oxidation number is 0. So aluminum is 0. Same for iron, it's in its elemental state, so its oxidation number is 0. And our aluminum oxidation number is +3 because it is in its charged form, which means its oxidation number will be the same as its charge. So the words underneath say, aluminum is the goat in this reaction because each aluminum goat is providing 3 electrons. So the goat is being oxidized, losing electrons. So aluminum is going from 0 to +3. That means it's losing 3 electrons. Iron, on the other hand, is the wolf in this reaction because it is gaining 2 electrons. It is consuming 2 electrons. So for iron to become 0, it needs to gain 2 negative charges, or 2 electrons. Remember that you can't take half of a goat, you can't split things in half and leave an electron by itself. So for every aluminum that gets used, you will produce 3 electrons for the reaction. Iron only needs 2. So we have a misbalance of electrons here. So in order to make these the same, we have to use a common factor. For every 3 electrons that aluminum provides, iron only needs 2. So if we look at common factors, the common factor of this would be to have each of them, for aluminum to provide 6 and for iron to need 6. So therefore, if we need 6 electrons from aluminum, we would need 2 goats. And if we need our iron to consume 6 electrons, we would need 3 wolves. So this is how we get the balancing. So 3 irons, and we would need 2 goats. And now we need to balance the other side as well. We have 3 wolves on the reactant side, which means we're going to make 3 irons over here. And we're going to use 2 aluminums, which means we'll end up with 2 aluminums on the product side. And that is how you balance this first equation.